Okay, Bismillahirrahmanirrahim. Dear students, in today's lecture in the morning we studied Thevenin's theorem, and it says that any given circuit like this one, it can be equivalently represented by a Thevenin circuit, which says it should have a voltage source which looks like V Thevenin, we call it V Thevenin, and a resistance which we call is R Thevenin, and that these two terminals, uh, which is the load terminal, we call it this A and B, which is like A and B over here, and you connect the load resistance, okay, across this A and B. So any network, given network, can be equivalently represented by a Thevenin circuit. Now to find this R, so in the Thevenin circuit we have two unknowns, this R Thevenin and V Thevenin, the resistance and the voltage. Now for the resistance, to work out the resistance, so what we should have, we should redraw our this given circuit. So we can say that okay, this is okay the 6 ohms resistance, then we have the 2 ohms, the 2 ampere current, this is 6, right, and this is actually or 12 volts, right, and then we have a resistance connected 6 ohms, and then we have 4 ohms resistance connected, which is over here, and then this is A B terminal. Now we remove this load resistance, which is 1 ohm, and it becomes an open circuit, so we can find then R in. So if you find the input resistance, it will be equal to the R Thevenin, right? So to find the R Thevenin, we say we should make the voltage sources, any voltage sources should be short circuited, and any current sources, right, it can be made as open circuit, right? So we have one voltage source and one current source. So by applying these two rules, our circuit becomes what? Our circuit becomes from A, if I go from the A terminal, okay, then I have this 4 ohm resistance, this is my B terminal, then this is 6 ohms. Now remember, I would ignore this part, which is 2 ampere current, this branch which is open circuited, then I have the 6 ohms resistance, right, and this would become short circuited, right, over here. So basically the source over here, this point, it becomes short circuited. Now okay, so R in becomes now easier to find. It's if you have these two resistances in series, so I can write this as okay, the summation of two resistance is 12, then this 4 resistance I keep as it is, right, and then we can say this is where you can write R in. So this is your 4 ohm resistance. Now if you see this 12 and 4 are in parallel, so the formula for this equivalent resistance would be R1 plus R into R2, so it will be 12 into 4 divided by 16. So if you solve it, you will get a value of 3 ohms. So it means that the equivalent circuit, okay, equivalent Thevenin circuit are okay, are the resistance of that is calculated to be 3 ohms. Okay, now what should be the value of now V Thevenin? And remember, I can make it again over here, it was like V Thevenin, okay, and then R Thevenin, okay, and then we have A and B port, and this is the area where we connect the load, right? So this is known to be now 3 ohms. What about this thing, V Thevenin? So for V Thevenin, okay, we have to analyze the circuit again without the load, right? So in order to analyze the circuit again without the load, I would redraw this as okay, plus minus 12 volts, right, then I have this 6 ohms, right, then I have this 2 ampere, okay, which just goes like this, and the 6, okay, this is 6 again, and then I have 4 ohms, and again this is where your terminal are open. So basically this is terminal A, this is B, this is 4, this is 2 ampere current, this is 6 ohms. Now we can solve. Now if you see, now this is open, so this is open circuit, V open circuit, which is equal to V Thevenin. So the voltage over here, is V Thevenin. So this voltage appears across this force or resistance as well. So if we need to find, if somehow we find, okay, V4, the voltage across the 4 ohm resistance, which is equal to I times the resistance, which is equal to, we don't know about I, and the resistance we know is 4. So we need to find current in this branch, right? Current over here. So you find the current in this branch, so we can then manage to find the voltage V4, and it will become V Thevenin, right? So you can use okay, so to find that current, so you can use mesh method like this one, okay, I1 and I2. You can use nodal analysis by selecting nodes, okay. You can use source transformation.